Okay, Module 5, Lesson 1 starts out introducing this guy named Tails. And I'm going to let you read through this, but Tails is credited with um, the following points here. It says a circle is bisected by the diameter, and that should make sense. It cuts it in half, doesn't it? Every angle inscribed in a semicircle, half a circle, is a right angle. Now, you guys, what that just said is if I have a circle and I have a diameter, and we know that that diameter cuts it in half, then every angle like this means that that's going to be a right angle. It doesn't matter where that is. Okay? If two straight lines intersect, the opposite angles form are congruent. We know that, right? Those are vertical angles. The base angle of an isosceles triangle are equal. The sides of similar triangles are proportional, and two angles are congruent if they have two angles, or two triangles are congruent if they have two angles and a side respectively congruent. And that was the angle-side theorem. This is the one we are going to focus on today. So what we're going to do is we start with just simply drawing any triangle, and it really doesn't matter what that triangle is. That's not a very good triangle. Let's try that again. Okay, so with this triangle, what they're asking us to do is literally take this and cut it off, take this and cut it off, take this and cut it off. And what you're going to find is that when you do that, those three angles put together add up to uh, this, which is 180 degrees, which we already know that the three angles of a triangle add up to 180 degrees. So hopefully that makes some sense. Thales' theorem is this. Given 2 points, A and B, which we have over here, and P, the center, the midpoint of those two, right, between the circles, if C is a point such that angle ABC is a right angle as marked, then we know that, and this is kind of interesting, this seems to be off to a tangent, that AP, it's not P, AP equals BP, which equals CP. And notice that CP is a radius. So these are all radii. And we know that all radii of a circle are congruent. All radii of a circle are congruent. Then they said the converse of Thales' theorem says that if angle C is a right angle and P is the midpoint, this is P, between A and B, then these are all radii, right? Implies that the circle with center P with radius AP contains the points A, B, and C. And what they're saying is that there's going to be a circle here. So that circle, notice, has points that intersect 1, 2, 3 places, and you have the same diagram. Okay, so some definitions. Given circle C, they're going to name a circle by the center. In a plane, the number r greater than 0. In other words, in order to have a circle, you have to have a radius that is bigger than 0. Distance, the radius is that distance from R to C, or distance R of circle C. So that's R. Radius may refer either to a line segment joining the center of the circle with a point on the circle, or the length of the line segment. So either way, the radius is represented distance from the center to the circle. The diameter is going to be the distance all the way across. In other words, it's if this is R, then this is 2R. a chord. Now, this is a new term here. Chord is a some point PQ, P and Q um, of circle C. Remember, this is still circle C. Now, the chord does not necessarily have to go through the middle. If the chord does go through the middle, then the chord is a diameter. So you can call the diameter a chord. That's O-R-D. And then lastly, the central angle is an angle of in a circle. A central angle of a circle is an angle whose vertex is the center of the circle. So they're saying here's C. This angle here is called a central angle. All right, so let's take a look at a couple problems. AB is a diameter of circle shown. The radius is 12.5, so we know right away that if the radius is 12.5, then the diameter equals 25 centimeters. AC is 7. This looks like we know this is the diameter, so this is a right triangle. We know then that this is a 7, 24, 25 Pythagorean triple. That means 24 centimeters, right? And you could solve that using the Pythagorean theorem, but those Pythagorean triples are going to come in handy again. They're asking us to find the measure of angle C. Measure of angle C is a 90-degree angle. AB, we know, was 25, and BC is 24. And you'll notice that what I did is I took the information that was given to me and I sort of implied additional information as I went. So I sort of filled things in I knew, not that I assumed, but what I knew. Number 8 says, what is true about all the radii of a circle? All radii of a circle are congruent. How can that help you solve problems with circles? Well, clearly this problem that we just worked, if that's 12.5 and that's 12.5, that gave me my diameter. So any diameter that's or any radius that's drawn in here, we know is going to be 12.5. That may help in terms of this distance at some point also. In the circle shown, BC is the diameter. All right. So AB is a radius with center A. Find angle DAB. We're looking for angle DAB, this angle here. Hint, think about the sum of the angles of a triangle. Well, this is kind of interesting. So we know that all radii are congruent, correct? And those two are both radii. That means that this angle here is also 18 degrees. So I know that this angle here, measure of angle DAB, has to be 180 degrees minus 18 minus 18. Or 144, and you can use a calculator for that. So we found out that this is 144 degrees. That's pretty cool. Find measure of angle BAE. BAE, we're looking for this angle now, right? Well, basically, we also know this is also a radii, so this now is an isosceles triangle, and that's 26. So we know BAE is equal to 180 minus 26 minus 26 equals 128 degrees. Then lastly, it says find DAB DAE. Hint, think about the sum of the angles around point A. Don't we know that the sum, whoa, that the sum here is going to be 360? So I can pretty much guarantee you then that measure of angle DAE is going to equal to 360 degrees minus the 144 minus the 128, right? This was 128. And therefore, this is equal to 88 degrees. And yes, you should be using a calculator. Okay, that's a good introduction to circles. You've got your theorems here that you're hopefully paying attention to. You know you've got a right angle. You know you've got all radii are congruent. You've got diameter. Good luck.